Hi guys, this is Miss Raina here at C347 in MacArthur High School, coming to you to talk about impulse today. So we're going to continue from your same worksheet, and you'll begin on the section entitled impulse. So it's defined as the product of, and here you'll fill in, net force and time. It's definitely a vector, so it's not a scalar, and it's in the same direction that the force is applied. An impulse is defined as a change in momentum. So if you do force and time, really what you're calculating is how much the momentum has changed. Since you're doing force and time, you've got units for newtons and seconds. Why is there a negative sign? Well, because the change in momentum is going to be opposite of the way that the force is applied. All right, go ahead and write this into your equation box for impulse. It's force times change in time. The impulse momentum theorem tells us that force times time is equal to the change in momentum. That means impulse itself is equal to change in momentum. So a change in force over time creates an impulse. Here it is again, the impulse momentum theorem. If you haven't already, make sure you write this down in your equation box. So let's take the example of coming to a stop sign. And if your dad is driving, then he's real careful with everybody in the car with you, and he goes really gently on the brakes if he's feeling like he's in a good mood that day. And if he's really gentle on the brakes, that means he's applying less force. It means you come to a stop over more time, it feels a lot easier, a lot steadier. If, however, he jams on the brakes and applies more force, well, he's going to come to a stop much quicker. That's something you might want to do if somebody surprises you, jumps out in the road in front of you or something like that. How does the difference in momentum change in the two situations above? Either way, you're coming to a stop. You're just doing it quicker or slower, depending on how much force you apply. So let's think about, how do airbags work? If we're in a car and, God forbid, you're in a crash, you want to make sure there's as little force being applied to stop your motion going forward as possible, as little force on your head specifically. So how do you decrease the force? You increase the time. Let's think in terms of sports science. So let's take one kind of ball and the other kind of ball. You drop them both from the same height. One bounces back up right away. The other one, maybe it's flat. Maybe it doesn't bounce very much at all. In which case is the impulse given to the ball by the floor the biggest? Well, if we think about it, impulse means change in momentum. How much can you possibly change the momentum? So the bigger change in momentum happens when the ball starts off with a downward velocity and finishes up with an upward velocity, as opposed to just losing its downward velocity. That means you get the bigger impulse, the bigger change in momentum for the very first case in which the ball bounces back up. Let's try an example that has to do with an actual problem we're going to solve. All right, so here's our first sample problem, and we can see that they've given us a mass. They've told us, let's see, an initial velocity, and that's going toward a midfielder. And then it ends up being shot toward the goal at this final velocity. If the person kicking the ball was making contact with the ball for this much time, we're supposed to figure out what was the average force on the ball. Well, we're going to use the momentum impulse theorem that says force times time equals the change in momentum, or mass times velocity final minus mass times the initial velocity. In this case, we're supposed to figure out what is the average force on the ball, and so what we need to do is divide everything by the amount of time involved. So in order to get the force, we'll have to figure out the mass times the final velocity, so 0.425 times the final velocity, which is 26 meters per second, minus the mass times the initial velocity, which is 6 meters per second, going in the opposite direction. So this will end up canceling the minus sign out, And now we have to just divide this whole thing by the time involved, 0.008 seconds. At this time, go ahead and pause the video so you can. All right, now we're going to go ahead and calculate, punch it into the calculator, and you should get a force of 1,700 newtons. Whoops. Okay. It's still a little bit difficult for me to get used to writing using the Smart Slate, so sorry about the work being a little bit messy. Let's try. Actually, we're done with this video. We got a nice little 5-minute 30-second video, so we can go over that problem a little bit more in class. Meanwhile, I want you to write down any questions you have for me next time in class. Please, please, please be ready for a quiz tomorrow over this material and the earlier material in this same handout titled Flip Notes, Momentum, Impulse, and Collisions. Thank you very much, guys. Have a great day.